All right, so example 3 is a little bit different. It says dilate triangle ABC with a scale factor of 2. Okay, so that's our K value, using B as the center of dilation. So notice your center of dilation is no longer at 0, 0. Excuse me. So you've got to do a different method here to find A prime, B prime, and C prime. All right, so notice B is the center. That means that point B is not going to change. So B and B prime are actually going to be in the same location. All right, so B is at 3, 5. Okay, so that means B prime is also at 3, 5. Okay, we are dilating about this point. All right, to find A prime, first we're going to look at point A. Okay, so using the point B, so B is our center, notice how it takes 1, 2, 3, 4, 5. So 5 jumps to the left, and then it goes down 2 to get to point A. All right, since we are doubling it, instead of going to the left 5 to find A prime, we are going to double these two numbers. All right, so 5 times 2 is 10, and 2 times 2 is 4. All right, so we're going to go left 5 more to get to 10. And then we're going to go down 1, 2, 3, 4. So notice you're just doubling it. So there's A prime. Okay, if the scale factor would have been 3, we would have tripled it. If it would have been 4, we would have quadrupled it. You get the point. All right, so we're going to do the same thing to find C prime, okay? So notice we go 1, we go to the right 1, and down 1, 2, 3. Okay, so that's 1 and 3. Okay, to get to C prime, right, we just went to C, now we need to get to C prime. We're just going to double those distances, all right? So 1 times 2 is 2, so we're just going to jump 2. And then 3 times 2 is 6, so we're going to go down 6 instead. Okay, so we should end up right there. And that's where C prime is going to be. All right, so I'm going to erase all of this so we can actually see what's happening here. Give me a second. Okay, so now your new figure is dilated about B, and it is still twice as large. All right, so that's the difference there. So now all you're going to do is go and find those coordinates. So A ends up being, or A prime, sorry, excuse me. A prime is going to be at -7, 1. And your C prime is now at 5, -1. All right, so that's how you do that using one of your points as the center of dilation, okay? So let's say if C would have been the center of dilation, then C prime would have been left alone. We would have used the same coordinates. So hopefully you get what's going on there. All right, example 4 says dilate triangle WXY with vertices W, 7, -4, X, 13, -10, and Y, 1, -13, with a scale factor of 1/3, so our K value here is 1/3, using the point 4, -1 as the center, okay? So this one's a little bit different. We can't use the origin, okay? And we're all of our points are going to end up moving, okay? Because we're using a different point as the center. Okay, so the way you're going to start this off, I want you to just go ahead and graph those points. So I need you to graph W, X, and Y. I'll do it with you. Okay, take note here. This is your X and Y axis, so make sure you're using those correctly. Okay, so W is at 7, -4. So there's W. X is at 13, -10. I'm going to count for a minute. Believe it's right there. So there's X. And then Y is at 1, -13. All right, so there's y. All right, I am going to go ahead and connect those dots because I know it's a triangle. All right, and we're using the point 4, -1 as the center. So I'm going to put a little point at 4, -1. Okay, there's 4, -1. I'll make it a different color for us. That probably wasn't our best choice. I'll make it green. 4, -1. Okay, so you're using that as your center. All right, notice here, this is the center. So this is where you're going to start. So we're going to start with point W, and we're going to do some counting here. So notice how to get from point W, we go to the right 3, and we go down 3. So I'm going to write 3 and 3. Okay, we are shrinking by a factor of 1/3. Okay, so I'm going to divide both of these numbers by 3 or multiply by 1/3, whatever you want to say. I'm dividing them by 3 because it's shrinking, right? Okay, 3 divided by 3 is 1. So instead of going to the right 3, I'm going to go right 1. And instead of going down 3, I'm going to go down 1 from that point at 4, -1. Okay, so here is my W prime. Let me erase all this other work. Oh, maybe. Okay, so there is W prime. Okay, we're going to do the same thing with X. So to get to X, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we go right 9. And when you go down, 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. So we went right 9 and down 9. All right. Again, we are shrinking by a factor of 1/3. So I'm going to divide by 3. Okay, well, 9 divided by 3 is just 3. So for my new point, instead of going 9 and 9, I'm going to go 3 and 3. Okay, notice how it lands right on top of W prime. That's okay. I'm going to use pink for this new image. Okay, that just means that X prime sits on top of W. That's okay. That can happen. All right, so last but not least, let me erase that work that we just did so it can get out of our way. Okay, I'm still using 4, -1, and now I'm going to count to Y. So it looks like we go 1, 2, 3 to the left, and we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we go down 12. So again, we're just dividing these numbers by 3. Okay, 3 divided by 3 is 1, and 12 divided by 3 is 4. So I'm going to go to the left 1 and down 4. All right, so there is Y prime. Okay, again, you have to use this method because this was not about the origin. All right, so here's our new figure that's been dilated by a factor of 1/3 using this 4, -1 as our center. All right, so W prime ends up being at 5, -2. X prime ends up being at 7, -4. And Y prime ends up being at 3, -5. All right. Example 5 says triangle ABC has coordinates with A at 0, 3, B at 3, 6, and C at 6, 0. Give the new coordinates of the triangle after it has been dilated with a scale factor of 2/3. Use the origin as your center. Okay, that's really good for us. That means we can use our dilation rule. Okay, so what I'm going to do is I'm going to take my original points, so A, B, and C, and all I'm going to do, since we're using the origin as our center, remember we can multiply the x and the y values by 2/3, which is our scale factor, right? So if you multiply, let me switch my color real quick. If we multiply everything by 2/3, that means that A prime is going to be at 0, 2. B prime is going to be at 2, 4. And C prime is going to be at 4, 0. So again, you're just multiplying the x and the y value by that scale factor. All right, and then that's all you have to do. That's all that question wanted us to do. All right, sequences of transformations, that's when 2 or more transformations occur. So we're just going to do one example on this one. So in example 5, it says triangle RST has vertices. R is at -3, 7, S is at -2, 1, and T is at -5, 2. Rotate triangle RST 90 degrees counterclockwise about the origin, and then reflect it across the y-axis. So you have 2 different transformations happening here. All right, so the first thing we're going to do is rotate it 90 degrees counterclockwise. So remember in class, we wrote down some rules for the clockwise positions, okay? So 90 degrees counterclockwise is the same thing as 270 degrees clockwise. So I'm going to go ahead and use that rule. Okay, if you look at your fact sheet or back at your old notes, we use the rule -y x. All right, hopefully you remember this. Okay, so R prime, okay, our original R was at -3, 7. So my R prime is going to be at -7, -3, right? I'm making the y negative and keeping the x the same. Okay, S prime, using the same rules, we're going to be at -1, -2. And then T prime is going to be at -2, -5. All right, so that's what happens when we rotate it the 270 clockwise or 90 degrees counterclockwise. Okay, it was about the origin. Sorry, I didn't mention that. That's why we were able to use that rule. Then reflect it across the y-axis. So we have one more thing to do. We have to do a y-axis reflection. Okay, if you look back at your notes, when we reflect across the y-axis, that changes our points to -x, y. All right, one thing to point out here. You are going to use these points to reflect across the y-axis. So these are the points, that you're applying this reflection to. All right, so when we use -xy, that means our double prime, right? We're going to call it something different. Our double prime is going to be at 7, -3, right? It was at -7, -3. I'm just making the x negative. So -7 is +7. All right, S prime, okay, S prime is going to be at 1, -2. And then T double prime, sorry if I said S prime, I meant double prime. T double prime is going to be at 2, -5. All right, so this guy is going to be your final answer. All right, that's what you get after you apply both of those transformations, okay? So we're going to take a second. I want you to graph your original image, and then I want you to graph this image right here, okay? So let's take a second to do that. So there's R, there's S, and there's T. There we go, that's a triangle. Okay, and then R double prime is at 7, -3. So there's R double prime. S double prime is at 1, -2. And then T double prime What did we say there? 2, -5. So there's t prime. All right, so all we did on that one was apply 2 different transformations. Not too difficult. All right, if you have any questions, please come see me. If not, have a great rest of your day.